Hello, good morning, and thank you for joining me in my shop here. It's July 10th. The hurricane has hit. Yes, the hurricane has stretched all the way up to here, up in the Great Lakes. Except here it's not a hurricane, it's just a big bad rainstorm. It's going to go on for hours and hours, probably a day and a half or something like that. So we're going to get a lot of rain, but that's about it. Gray sky and just steady, steady rain for a long, long time. So, after yesterday's experience with this radio and other things I've done with this radio, playing it in its listening post and that, so I've become familiar with it, and looking underneath it and seeing the kind of capacitors that are in it, which is the primary component that wears out in these older radios. There are none in here. They're all high quality, highly reliable capacitors. Probably most well, who knows, but the performance issues with the radio, there seem to be a few, are probably related to either bad tubes or bad alignment. That's my guess, and it's not really a component issue. Bad tubes. So the tubes in this radio are all common tubes except for one. There is one tube which is not common. And I've looked into this tube already to find out a little more about it. It's the 6BV8. And it's a detector, used as a detector tube. It's similar to so many detector tubes in radios like this, including smaller ones. Smaller, even 5-tube radios have a detector tube that's usually doing a couple of jobs. One is it's doing the rectification of the IF output, which is the detector part, and it may have one diode or two diodes in the tube. And it usually has a triode, a separate triode amplifier. And the reason for this is it's just very handy that radios require these tube functions, and the radio manufacturers are able to stick them inside one glass bulb. So it's two tubes in one, or even three tubes in one, because there's two diodes. So this particular radio, the 6BV8, is doing that job, but it's not like other tubes. Now, the 6BV8 is new enough, it doesn't even, well, it shows up in this manual, but only in the back in the table. But there's some other tubes that are similar we can take a peek at. Then I'll show you the 6BV8 from a web page. We can take a look at the, because I can't find it in my tube books. I can't find the layout. Look at this diagram now. This is for a different tube, 6BW8, not the BV8. They're similar in function. Oh, this is not a triode, is it? Sharp pentode. Oh, okay, so this is not similar. This is not, we shouldn't even look at this, but we will look at it for this one purpose. See the two diodes there? And right below them is one cathode, a shared cathode. If we look at other tubes that do this job, two detectors and a triode, and I wanted to find one, and I forgot about it when I went and drank some coffee and forgot to look one up in here to show you. So I'm going to stop and find a typical tube. 6AV6. You know what? 6AV6 will do it. 6AV TUV TU TUV 6A. How's that alphabet work again? Oh, there's too many U's. 6AV6. Okay, so look at the 6AV6 here. Now, a little out of focus on my camera. So you see the triode right in the middle. The two diodes are off to the side there. That looks like pins. I'm not even sure what pins those are. But if you look at the cathode, you can see the two diodes off to the right-hand side there. See, the thing is, it's one cathode for all that stuff. And that's what you commonly find in 5-tube radios. Just one cathode. Two diodes and a triode sharing a cathode. I believe this leads to the problem I've encountered in the 5-tube radios where you can't turn the volume down. It won't go away completely, because I believe this tube with its common cathode is sharing too much between the diodes and the triode. And so the other tube I showed you here had two cathodes, one for diodes and the other one for the pentode, which we could pretend was a triode. The thing about the 6BV8, let's look at it on my computer screen here. Just one second. so I'll edit out the 1 second here. So here we are, 6BV8. Here you see the layout, and you can see the 3 separate cathodes. So that makes this actually a more versatile tube, and it's probably not going to cause that problem I mentioned where the shared cathode starts sharing what's going on inside the tube too. So you end up with the rectified output getting right onto the triode and heading out to the speaker. Never mind the volume control, you don't even need it. In a worn out tube, I should say. And of course that's what we mostly have. So this one avoids that problem. And I see the 6BV8's been used in a number of Hammarlund radios, so they liked it. Unfortunately, I don't have any of these tubes. So we're going to find this in the radio, and this is going to be the first tube that I test. My objective today is to test the tubes. I don't know, did I say that? Because it's either alignment or weak tubes that are causing performance issues in the radio. So we're going to start off with tubes now. So yeah, a lot of these are in metal shields. Look at the tube diagram here on the back. That's the best way to find it here. 6BV8. Where are you? There it is. Down here. Okay, so if we put this like so, I see it. This guy should be it. Come on out of there. Wow, it's really held on. You can actually look inside this tube and you can see that they're can you see it in the camera? You can't see it in the camera. Totally separate sections. One there, and then one kind of behind the one you can't see. I imagine these two that are close together are the diode, and the triode is over here. Completely separate. Apparently the heater is just one series heater in here. And what, 6BV8? Yeah, definitely 6BV8. So testing this tube is a problem for me too. I bet I'm going to have to try to find some kind of supplementary guide to find the, because if it isn't in the tube manual, it's too new to be in my tube tester, certainly in the roll chart. But why don't we just take a peek at that? Let's see what's up here. These are my Lyman's high voltage rubber gloves, protective liners, in case you're doing some high voltage work. Okay, 6BV8. I'm sure it won't be in here, but let's look. Because if it is, it's going to save a lot of time and effort. 6BV. TU6BV8, it's there. Or is that BV6? You see, I'm surprised. It's there, 6BV8. Excellent. Interestingly enough, they're using a setting up here on the filament volt setting, which is unusual. So normally a 6-volt tube gets set to 6 here. But here they're saying put it on 0.6A. 0.6A. Now, I don't really know what this is for sure, but I'm going to guess 600 millivolts. 600 milliamps rather. 600 milliamps. This is some kind of current supply. I don't know, but that's what it asks for. Not a common setting. Okay, I'm able to test the tube here. Fantastic. Well, this is the one tube that's going to be a big problem. So I'm going to keep the video going here. There, you can see the pointer now. I can't see anything else though. 6BV. So signal level 4. 14H. 14H, that's the bias setting. 15376. 15376. 0000. Really? Never had a tube with those settings. 39 on the sensitivity. F for the plate. This is the triode test. Should come up to about here when you go to do it. Okay, now we're going to double check this. I said I don't have a replacement. I can't afford to blow this tube up. 14H. 15376. 15376. Now a pile of zeros down there. 39. F, very important. Okay, we're good. Should turn this on. Oh my gosh. I have to turn it on this. Turn on lots of stuff here. There we go. Of course, we know the tube works because the radio works. What we don't know is how well it works. And even if this comes up bad, with no replacements, and there's no alternative tube. There's no substitute tube for this. When tubes were later in the manufacturing history of tubes, there was no further advancement, so there were no further replacements, so there was no improvement on this. And I don't know how you'd improve this, because this is the improved tube, the separate cathode, I would think. Okay, in short test, none. And coming up to here, nothing at all happened there. The tube is not heating. These are all set to zeros. I think these are the filament settings generally. I've never used this setting before. What happens if you put it on 6 volts? Can't risk this tube. Why? So I don't fully understand this 0.6 setting. And I don't understand putting these all to zeros. Interestingly enough, when you're testing the diodes, these are set. Well, let's go on to the diode test then. I think the test has failed. I don't think the tube has failed. I don't think it heated up. There's something about setting it here and having these all zeros. I wonder if that's the usual way or something. I don't know. Okay, let's change the settings then. We'll do the diodes. Do the diodes. Signal level, I can't see what I'm doing. Okay, so it's a diode. There's no signal in this test. The numbers are 00076. P1K3, another weird P1K3. 38, same spot, A. P1 and P2, K1, K2. So what it's saying is there's 2 plates and 2 cathodes. So we have these buttons, these switches here. When initially you'll test one set of plates and cathode, then you flip the switches and test the other set. Okay, let's see what happens now. And it's 0.6. It's still the 0.6 thing, isn't it? 0.6. 0.6. what happens now. Please don't damage the tube. Again, it's not showing any heat. Okay, so maybe I could take a guess that this setting here is not functioning properly in my tube test. I was so excited because it had this tube listed in it. But then I won't. So what happens if I just move this over to 6.3? I probably get invalid test results. Is probably what I get. That probably doesn't hurt the tube, but I don't think I really want to find out. Okay, shorts. There's no heating in this tube. I don't think this is working out at all. I don't think it's working out at all. So we're going to push the rectifier and diode switch. Yes, it's not listening. It's not heating. It's this. Oh! Tube's okay. Tube tester failed. That's like saying the operation succeeded. Patient died. Okay. Pull that out. Well, that's disappointing. That's totally disappointing. This is the one tube I'm quite worried about. I'm going to put it back in the radio for now. Yeah, I have to find out what this 0.6 thing is really all about. See if I can find my manual for that. Well, here are the instructions for the tube checker that I am using. Let's see what we can find out here about it quickly. Okay, I'm making some headway in understanding why I don't understand why I'm supposed to use this 0.6 setting, but if you look if you look right here, you see 6.3 volts, and right there 0.6. Now you would think, well, what's the problem here? You put 6.3 volts on the filament, you get 600 milliamps. Well, why is this an issue with this tube? So if we ask Bing, hey Bing, my Weston 981 tube checker has a filament setting of 0.6 amps. What's that for? Here's what it says. I had to think about this for quite a while before it came back with a response, by the way. Almost 15 seconds. The filament voltage setting of 0.6 amps on your Weston 981 tube checker refers to the current supplied to the filament, or the heater, of the vacuum tube you're testing. Vacuum tubes require specific filament voltage to operate properly. By setting it to 0.6 amps, you ensure the filament heats up to the correct temperature, allowing the tube to function as intended. But yeah, well, why wouldn't I just set it to 6.3 volts? So this doesn't really explain why this tube requires this approach of a current source. Okay, we're not done yet. So if we look at the manual, and this part of the manual, I finally found it. I had to read this thing over and over to spot this. Near the upper left-hand corner of the panel is a filament voltage switch marked filament volts. On the roll chart under fill is the correct setting of this switch for each tube type. A constant current supply of 600 milliamps is available for the testing of series string TV tubes. This supply is connected between the is connected between the 2.5 and 3.3 volt positions on the filament transformer and is marked 0.6 amps. Series string tube types are listed on the roll chart with a filament setting of 0.6 amps. So, I don't understand this. Let's look at the schematic for this radio and just see how this tube is being treated. Is it being treated somehow differently? Now the schematic is one of these. How about this one? Yeah, I think it would be down at the end of this. We can find it way down here somewhere. Here we are. Oh, it's a 2-pager. So looking for a couple things. One is the mouse, you're going crazy. The filament connection diagram. Here it is here. Oh, V numbers. So we need to find, should be able to recognize it finally. Here we are. This has got to be it. 6BV8. Here's part of it. V7A. Okay, V7A. V7A is going to be, oops. What am I doing? I'm looking down here, confused. V7. So yeah, look at V7 has got a resistor in here. So what's the supply out here? It must be a 6-volt supply. Does it say it anywhere? All these tubes are 6-volt tubes, are they not? Are they not? Okay, let me just look at the tube thing for a second, because they must be 6-volt tubes. Of course they are. Of course they are. They're all 6-volt tubes. But for some reason, this tube operates with a big resistor here. 5 watt. Like, it's really knocking the voltage down here. I think that answers the question. Don't test it at 6.3 volts. The other thing is, as they mentioned in the manual, the setting is between 2 voltage settings. 2 lower voltage settings, which might be similar to the voltage that's dropping, you know, when you have the 0.6 going through. I don't understand. This is crazy stuff. Well, what does it say in the tube manual? We'll have to take a look. So is there anything else special about this? Did I just see the resistor? Any other tube being handled that way? No. Just this one. Oh my. I don't want to make a mistake with the tube. I do not have a replacement for it, and there is no substitute. So if we look at this rate in the circuit, they probably don't show this part in up here. Yeah, they don't. So here's half. Where's the other half of V7? V7B. Where's V? Here it is, over here. So nothing unusual about this, the way it looks. It's awfully busy. Look at how busy this is. Holy smokes. Well, there's an adjustment right there. Would that be tone control? What would that be? Look at this. What's going on here? I don't know. That's the fun of doing this stuff, looking at stuff that you've never seen before. Remember earlier when we were looking in the back of the radio, yesterday's video, I pointed out 2 sort of integrated circuits, although that's really not the right word for them. Here they are here. Here's one of them right here, and look what's inside it. 2 capacitors and a pile of resistors. But you know, you could make this. You could make this externally. If it were to fail, like if this capacitor fails, you can remake this. You can also, in some cases, and I've been lucky enough to do this, you can have a component fail inside here, and you can manage to replace it outside, if you're lucky. You'd have to be kind of lucky about how this is arranged. So lots of parts in here to go, and I don't think these things are reliable. Okay, so what do we do now? So clearly we can't test that tube without using the 0.6 setting, and the 0.6 setting appears to be defective in my tube checker. And why would that be? Probably because somebody previously did something, not me, somebody did something wrong with this setting on the tube checker and burned it out. A 5 watt resistor. 3.3 ohms, just a tiny resistance in here. Okay, that's the story of the 6BV8 in this radio. I need to be very cautious around this tube, because again, no replacement, no substitute. Okay, wow, that's a long journey to this point. There's another unusual, I shouldn't say unusual, it's another tube in here which is not your normal tube. It's a voltage regulator tube. Probably not worth checking. What would be better is to check the voltage with the radio operating the tube in place and see if it's doing its job properly, rather than stick it in a tube tester. From here, all the rest of the tubes in this radio are just pretty ordinary stuff. I don't think there's anything too spectacularly special, other than the one I've been concerned about. Okay, coffee break time here for sure. Let's just take a peek at the hurricane here. So here's the remnants of it up in our area now. This is from the Canadian Government Weather Service here. I live right about here. Right there, as you can see right there. Orillia is where I live. This is Toronto down here. Montreal has just disappeared off the screen way up this way, in case you're not from around here. So here we are, Orillia. Let's put this in motion. Looks like most of the rain has gone by, and it actually is south of us down here, more or less in New York State. And where did I go? Here I am. Yeah, well, it looks like there's not a lot of rain left, really. How many hours would this take? Depends on how much the storm is developing down here, but it looks like it's not developing, so, you know, a few hours and it's over. But what happened to the 2 day? Oh, okay, all this is coming too. This is all going to head up through here. So it starts down here in the Gulf, which, you know, this is the Canadian Weather Service, so they're not showing you the map of the United States too clearly. But look, there's more stuff happening down in the Gulf, or somewhere down there. Anyway, okay, enough of the weather. I'm Canadian, you know, weather's a big deal here. Well, I think what I should do is just carry on with tube testing here and eliminate the possibility that there's a weak tube somewhere in here. Can't deal with this one properly, so we're going to have to do it by conclusion. If everything else is okay and there's still something wrong with this radio and it may have something to do with this tube, then it may be this tube. Otherwise, it's going back in. I don't think there's any particular order to do these in. I'm just going to go this way, go across or something like that. And I'm not going to do it on video because boring. Well, I've decided to show the test results of each tube as they're done. This is the 5Y3 rectifier tube. Has to come up above this point. Bingo, no problem here. Plate number 2. Perfect. Good. 5Y3. Perfectly good. Actually, the next tube to test is the 6BE6, which is infamous in this radio. Oh my gosh, what's that? Oh, these aren't twist, they're just pull up. Yeah, easier said than done. They did not leave finger room here. Let's see what I can do. Holy smokes. Whoa! I lift the whole radio up here. I can't believe it. How can this be so hard to get off? They are just clipped in. They're not locked in. Some better rocking motion might do it. Oh my gosh! Not expected at all. There's any trick here. Look where I put in my hands and all this pressure. This is where accidents happen. There we go. Huh. It's just really in there. So the 6BE6 tube, apparently when they made these sets, they sent them out in some cases with a Sylvania 6BE6 in it. And that turned out to be a problem too. So, who made this one? I'd never heard of such a thing before. Made in Canada. That's all it's going to say. There's no manufacturer's name. Well, sometimes these things are coded into the tube. There's
there's code numbers and tell you which factory it was made in and stuff like that. I didn't see any of that on here. Wow. I also see what looked like defects in the glass. Let me put the close-up camera on this. Oh, a little bit tricky. Close-up camera's looking over there. Okay, I'll see if I can show this to you just using the other camera, but I don't know. So, I don't think you're going to see it. Oh, I got the autofocus on. Maybe that'll help. Yeah. So, there's some weird shapes in the glass down along here. And you cannot see them. And probably means nothing. You can actually, I know what I'm looking for, so I can kind of see it up here. But okay, that didn't work out. But nevertheless. So, if Sylvania, I'm stunned that this is not branded in some way. It really isn't. Just Canada. Well, unless the radio exhibits whatever the problem was that tubing, causes. I think we'll just carry on. Okay, 6BE6, next one to be tested. Okay, small example of how fallible we are as human beings, at least me, anyway. So I've had this tube tester for a long time. I've tested lots of tubes on it. Every time I go to adjust this selector, what goes through my head is I'm deciding which pin is the plate pin. Even though it says right here, plate voltage. So when I was scanning the manual just a moment ago looking for information about this setting, I just, I suddenly realized this is a voltage selection. You're just going from a lower voltage to a higher voltage on the plate. It's a plate voltage, just like it says. But I got that other idea in my head. And even though I've stared at this and seen this time and time and time and time again, never corrected what was in my head till just now. So let that be a warning to any of you dealing with me. There's no telling what's in my head. So have we got this guy set now? I believe so. So we're going to put him to the test. By putting me to the test, I guess that's really what's going on in here. Okay, 6BE6, and a 6BE6 should test 1570, so pretty much just past the middle. Uh-oh, what's going on there? Nothing. Ah, nothing. How can you get nothing? How do you get nothing? You get nothing because something is set wrong. Oh, it's not really the case. 6BE6 4 8L and oh, for crying out loud. Just not quite enough light here. 51763 51763 3000 41 C. Voltude heptode being tested. 6BE6. This tube has to work or the radio wouldn't have worked. It's heated up. And it's there. So what exactly happened there? I don't know. There we go. So it's well above the... well, it's above. That's good. Okay, and that's the only test for this tube. Okay, next tube. Okay, here we go on a 6BZ6. It's supposed to come up to 1300, which would be about here. And it's well over. Very good. Okay. On to the next tube. Okay, this is the 6C4. A 6C4 on this tester should come up to 1430, so just below the halfway mark here. Wow, it's way over. Excellent. But there's actually 2 pins that connect to the plate on this tube. So to do the other pin, we do that. You should get exactly the same reading, same plate. Okay, 6E4. It's good. Okay, here's the first of 2 6BA6s. And it should come up to 960, which is just below the 1000 mark here. And we're over. Another good tube. Okay, I'm going to get the other 6BA6 and we'll test that one. Okay, this is the next 6BA6. Again, it should come up around 1000. And it's 1600, so it's testing very good. Great. Maybe this indicates this radio doesn't have a lot of mileage in it. Okay, well the next tube is a little interesting here. This is the 12AX7. And you see that there's yellow writing on it. Can you see the yellow writing is right on top of something? So this tube had a label on it, a white label, and then another label was placed over it. And it says oh, I forgot what it says. Realistic lifetime. That's the yellow stuff. The word realistic is right on top of the word made in Japan. So this tube's not like the others. The others were all made in Canada. This one's made in Japan. This is a replacement. Realistic, that was the brand from the store, from the I can't remember the name of the store, but I'm sure you do. And so somebody went and bought this at the store and stuck it in this radio. 12AX7. Well, we're going to find out about a Japanese 12AX7. I got to set the machine first. Okay, so if you're asking yourself, what's a 12-volt tube doing in a 6-volt radio? How's that work? That's the right question to ask. Incidentally, when I go to test this tube in this tube tester, the filament voltage is set to 6.3. Why is it called a 12-volt tube? So if we look at it in the book here, if you look very carefully, you can see there's a center tap on the heater. This one is in the center of the heater, and this allows you to run 12 if you want, or 6 that way. So you can get so you can run this in a 6-volt radio or a 12-volt radio. Now, let's see what happens. I think I have this all set now. So it's 6.3, and it goes in here. Holy smokes, that thing went like a light bulb there. I don't know if that probably came across. Let me carefully move my camera wire to the side. Yeah, that flashed like that too. Gotta wonder if it does the same thing in the radio. Okay, any shorts? Nope, no shorts. Now we're ready to do the actual test. This tube should test, let me just be sure I'm seeing this right, 12AX7, just over 1000. So just over 1000. Here we go again. Come on, tube tester. Like, this tube has to work. Ooh, what's going on here? Okay, hold it. Stop. Stop the presses. Something not right. Stop the presses. So, in a situation like this, the first thing I think is, oh, I've made a mistake. And I'm usually right. So 6.3 to 18L. None of those are going to stop it from testing. PGK77. PGK77. 3516. 3516. Now, is this a 12AX7 or is this a 12AX4? Am I testing the right tube? 12AX7. Yes. 12AX7. And this is definitely what I set it to. 12AX7. F. All buttons up. The light is on. The tube is heated. Tube is heated. Okay, wait a minute. Now this has to work. This I believe this is the preamp that drives the output tube, the 6AQ5. And since we heard the radio work, one more time. Now it's what? No, eh? Come on, this tube can't be like this. Well, I'm gonna have to put this in another tube tester. It's time to test the tube tester. Okay, this is a very different tube tester here. The principle of testing is different. This is just an emissions tester, but it's a nice one. It's a really nice emissions tester. So we're going to set it up here for 12AX7. Turn it on. Good. Lights up. That's showing the line voltage. Okay, we'll put it like that. And so it's a question of pushing these two rows of buttons down appropriately based on the chart down here. And then there's a release button. Like if you have some of these pushed, you release buttons. That's how this works. So 12, a little noisy. 12A, I'm going the wrong way. 12A, here we come. 12AX7, there it is. So we test this on this tester. We test it at 12 volts. So we're going to test the entire filament. 12 volts, and the top row of buttons is A123. A, easy as 1, 2, 3. A45 on the bottom. There's two tests for this tube. So we're doing the first test. Big wheel set to 35. That's where it is. W and X are the test buttons. Push them down and I'm testing the tube. Put this in here. Oh, flashed up again. That doesn't necessarily mean anything. I just don't like it. You know, how much voltage could you put on a tube like this? It's running with 12. Could you put 24? Could you put 48 volts on here and it would still work? I don't know. Surely you can definitely put extra voltage on these things. They don't burn out immediately. But to what degree, I don't know. Okay, first test is to look for shorts. On this machine, we don't look at the meter, we look at this light. Is there a short? Is there a short? No. No, there's no shorts. Okay, we're ready for the test. The test was WX. Let me double check. The test is WX. And it's just a good and bad. Ooh, she's weighing the good. Okay, now there's another test for this tube. So we pop the buttons, pop the tube out just in case it's not good to have it in there when we do this. So A127, A127, and A89, A89, 35 still, and the same buttons, WX. You see, these are the test buttons here. These are the setting buttons here, and these are the release buttons. Maybe they could have colored these a little differently or something. Okay, checking for shorts. Any short, no shorts. If a tube is shorted, it can be dangerous to try to test it. It can damage your tube tester, applying a test to a shorted tube. So you don't want to do that. WX. She's a winner. Okay, I don't know what's going on with my other tube tester, but just like me, they're getting a little long in the tooth. This guy did this is a fast tube tester. When I'm testing a lot of tubes, 30, 40, 50 of them, which occasionally I run through, I got a whole bunch I got to test. This is the tester I'll use because it's so fast. Okay. Why did I put my camera there? I don't know. I did though. So there remains only one tube, and that's the output power tube. This one here, a 6AQ5. 6AQ5 tube. Okay, so we'll just test it in that same tester in just a moment. Okay, here we go with a 6AQ5 output tube. Just want to double check these. I've got 237 right, and I've got AC156, 38 up here. Push the W button. No, check for shorts. Taint any. How do you test? The test button was W. Oh, it's climbing up. It means the tube is still heating up, I think. So it's just going to make it to the line there. So, you know, I guess back in the day, you could try to sell a new tube to the customer who owns this one. Say, oh look, it's you know, it's only going to get worse, Bob. We really need a new one. Yeah, but it might take a year to get worse. But don't tell Bob that. Sell him a tube. Okay. So I think this is good enough, unless for some reason we find the volume to be too low. This tube might be the guy. So basically I've tested all the tubes in here except this one. And they've all, did I test them all or did I skip these? No, these are the two, yeah, I did them all. Okay, all done. So no real problem with the tubes at all, which is great. Something else I've done here to make this a little better in the shop is I took these lights and I reversed them. They're supposed to be on this side of the thing, and then they're shining through the front, but it's so bright on camera you can't read any of the numbers. So I think if I just put the lights backwards here, they can stay on the radio. It's good to have lights because it reminds you that you've got the power on. If you don't have a light, ooh, sooner or later you're going to forget that you've got the power on to something. Okay, I think the next thing, what would be the next thing? The next thing would be checking the alignment. I'm kind of hoping a bad tube might explain some of the functions over here not working all that well. Alignment, I don't think alignment's going to affect this, but there's probably adjustments and settings, and there's probably measurements and voltages that can be measured. Yeah, maybe we should go through this and measure pin voltages. That might be good. I'm going to look for a table of that information, and that could be the next thing I do. Are the voltages correct on the tube? That's a good question. Okay, so I've been looking through the manual. There's a lot of stuff here when it comes time to align. There's also a chart of tube pin voltages here and a chart of tube pin resistances. Obviously this is done with the radio off, and you pull the tube out. Well, you may not even pull the tube out, I'm not sure. And switch measure from tube socket pins to chassis audio gain. Looks like you don't have to pull the tube out. You know, the idea of this, you can have the radio, this isn't the idea of this, but one way to make use of this is you can pull the tube out and test these resistances from above without having to poke around underneath. That's, yeah, well, that's not much of a point, is it? Not much. So we can avail ourselves of this information. Just by looking at the voltage regulator, the voltage should be 105, and yeah, there's not an awful lot of numbers here. Look what's popular. Pin 6 is a pretty popular pin. Like that plate all the time? I've never noticed that any particular pin is commonly used for any particular thing, other than pin 1 is often a grounding pin, but not here. Okay, we'll use this table and make these voltage measurements. Actually, considering what time it is here, I think I'm going to stop at this point for today, and then tomorrow we can pick up with the voltage measurements and the resistance measurements, and if those all check out, that pretty much says this radio is in top shape, and then it's all alignment and adjustment from there.
Not bad. Pretty good. Thanks a lot for watching, and see you on the next video. I don't see anything here specific to it. Controls. Oh, we have. There's grid bias. Roll chart abbreviations. It's going to be in this area here. Sorry, I'm kind of dragging on in the video at this point. Voltage regulator, tubes, precautions and testing. There's one in this radio. These are all special tube tests. I want special tube tests. Theory of operation. Perhaps it's got something written in here. Oh boy, I don't know. Okay, I'm gonna have to just hunt this down on my own.